everyone, welcome back to my YouTube channel. Today in this video I will provide you some of the important previous year questions of MSc second semester Kumaon University Organic Chemistry. So here it goes. Our first question is, write short note on rhenium ion mechanism. Rhenium ion. An rhenium ion in organic chemistry is a cyclohexadienyl cation that appears as a reactive intermediate in electrophilic aromatic substitution. For historic reasons, this complex is also called a Wieland intermediate. They are also called sigma complexes. The smallest rhenium ion is the benzenium ion, which is protonated benzene. Rhenium ion mechanism. The mechanism of aromatic substitution is known as rhenium ion mechanism. It is bimolecular and involves rhenium ion intermediate. In this mechanism, the electrophile attack on the substrate in the first step to give a carbocation known as rhenium ion intermediate or Wieland intermediate or sigma complex or benzenium ion. The leaving depart in the second step. The first step is the rate determining step. This is the mechanism of rhenium ion. This is the second step of rhenium ion mechanism. Rhenium ion is stabilized by resonance. Due to the loss of aromaticity, energy of activation is high. Thus, rhenium ion loses a proton and reverts to the more stable aromatic state. This is the second step in which rhenium ion loses a proton and gain its aromaticity. This is the second question. Write a short note on Heck reaction. The Heck reaction is the chemical reaction of an unsaturated halide with an alkene in the presence of a base and a palladium catalyst to form a substituted alkene. It is named after Richard F. Heck. Heck was awarded the 2010 Nobel Prize in Chemistry for this reaction. This reaction was the first example of a carbon-carbon bond forming reaction that allowed palladium-0, palladium second catalytic cycle, the same catalytic cycle that is seen in other palladium-0 cross coupling. The Heck reaction is a way to substitute alkenes. This is the mechanism of Heck reaction. This is the third question. Write short notes on ipso attack and E1CB reaction. Ipso attack. A position which is already occupied by a non-hydrogen substituent in an aromatic ring is called ipso position, and the attack on this position is called ipso attack. Ipso substitution. The aromatic substitution in which a substituent already present is replaced is called ipso substitution. This is the example, and this is the mechanism of ipso attack. This is step 1. This is step 2. E1CB reaction. E1CB stands for unimolecular elimination through conjugate base. In this reaction, a proton is abstracted by base to form a stable carbon ion. The carbon ion is converted to alkene by loss of leaving group in rate determining step. The elimination proceeds through the conjugate base of starting material. Therefore, it is known as E1CB. E1CB reactions are much less common than E2 reaction because of greater instability of carbon ions. E1CB is a two-step process. In first step, formation of carbon ion. This is the second step. Condition for E1CB. First, stabilized carbon ion. Beta hydrogen should be highly acidic so that the carbon ion may form easily. Reaction takes place in the presence of a strong base. Leaving group should be poor. Product formation generally takes place by Hofmann rule. These are the necessary conditions for E1CB reaction. This is the example of E1CB reaction. This is the fourth question. Discuss notes on any two of the following. A. Sharpless asymmetric epoxidation. B. Michael reaction. C. Wittig reaction. Michael reaction. The Michael reaction is a nucleophilic addition reaction involving the addition of carbanion to an alpha-beta unsaturated carbonyl compounds. It is also known as 1,4 conjugate addition. This is the mechanism of Michael reaction. In first step, nucleophile is formed. This is the second step. There is nucleophilic addition of carbon ion to beta carbon of unsaturated compound. This product is protonated and the resulting nucleophile changes in keto product, forming Michael addition product. Third step, protonation. Wittig reaction. The reaction between aldehyde or ketone with phosphorus halides to form alkene is known as Wittig reaction. Mechanism of Wittig reaction. First step, formation of betaine intermediate. Second step, formation of alkene. Now let's move to the last question. Discuss the effect of substrate, base, leaving group and solvent on the rate of reaction, E2 reaction. Effect of substrate. It has been found that branching at alpha and beta carbons increase the rate of E2 reaction because the number of substituents increase on the carbon atoms of the developing double bonds. The stability of the transition state increases. Effect of base. With the increasing basicity of the added base, the rate of E2 reaction have been found to increase. The order of basicity is. This is the order of basicity. Effect of temperature. As the temperature of the reaction increases, rate of E2 reaction also increase. Nature of leaving group. Better the leaving group, the higher is the rate of E2 reaction. This is the order. Nature of solvent. Polar aprotic solvents strongly favor E2 reaction because this favors the formation of the transition state of the reaction. So these are the some of the questions which were asked in the previous year. I hope this video is helpful for you. Thank you for watching my video.